Good afternoon. In today's video we're going to talk about the BFM II device. The abbreviation of this device is a branch feeder monitor. This solution allows you to monitor data on power consumption and parameters of electricity from several feeders simultaneously using only this device. I have on my desk right now a modification of the device with the function of recording emergency events, digital fault recorder. It allows you to record short circuit currents on individual feeder branches. That is why it's labeled with the DFR. As you may have noticed, this device is modular. The connection is realized by means of a side loop installed on the device parts. Later we will consider the connection of additional modules. As I have already mentioned, this device allows simultaneous monitoring of power grid parameters. Here you can see the terminals to which current circuits are directly connected. As you can see, 18 single-phase or 6 three-phase consumers can be connected. Now I'm trying to open these terminals. In the maximum configuration of the BFM II DFR, up to 12 three-phase or 36 single-phase consumers can be connected. The conventional BFM II can even measure up to 18 three-phase or 54 single-phase connections. Here we can also see the display of the BFM II, and this is where the voltage circuits are connected. The voltage model is a power supply model. Here we can see the PCM abbreviation. The device is powered from the measurement circuits. It's also possible to connect an additional voltage model. This makes it possible to measure the power parameters of several feeders from the one device. BFM II is also equipped with the communication interface such as RS485 and USB. The port is closed with a special flap. There is an Ethernet port on the top. Fixation of the device models is carried out by means of built-in locks, which must be turned after connecting the model. Also, we have here this indicator. It's called VH indicator, watt. On the panel of the device, it shows the registration of watts consumed or generated. It allows quick verification of the device in case of verification by metrological services. The voltage model displays a label with the necessary information about the device configuration, operating parameters and measuring ranges of current and voltage, as well as the accuracy class of the device. All BFM devices have accuracy class 0.5C. And as I mentioned earlier, the device has additional expansion models. I have on hand a model with 9 relay outputs. It's connected in the same way as the basic current and voltage models. Just like that. And I also have on hand a model for 18 dry contact digital inputs. There are wet models of different voltage range, 250 volt and 125 volt AC and 24 volt DC. Latching is also done by these locks. Using the integrated holes, the lock is screwed through and the modules are secured. So, we can read discrete signals, digital signals, send control signals by means of relays, and it's also possible to connect an analog input model to this device. There is a USB cable for pulling the device. Here, HAX current sensors, it's high accuracy current sensors, and as well as the stylus and additional accessories for attaching the stylus itself to device body, as well as an additional DIN rail clamp. Here you go. All of this comes in a kit with the BFM II. Regarding the current sensor, in this case I have a 100 ampere sensor. On the body of the sensor itself it's indicated the direction of current in which it should be installed. The maximum distance to which this sensor can be connected from the BFM II is up to 300 meters. It also has two outputs. White is plus and black is a minus. In the following I will show you which terminals of the BFM II are connected to which sensor. As you can see, this sensor itself is plugable. It can be installed without disconnecting the mains load. This sensor is directly connected to a measuring circuit with a load not exceeding 100 ampere. Now let's look how to work with the display of the BFM II device. I connected the hex transformer for the current inputs. Here you go, for the first current input and voltage input. That also a power supply module too. And when we turn on the device by using this tools, I am going to go for another menu of the BFM II. And when we turn on the device, we will see the voltage measurements. And now I'm going to see the RMS values for power for every submeter. And we can see through this menu a phasor. It also shows the RMS values for every voltage phase and the currents. Also we can see the currents as the maximum demand, as the RMS values too for every submeter. Also we can see the billing and consumption for every submeter. It means we can see the kilowatt import and kilowatt reactive and active energy import export for every submeter. Also we can check the RMS values of the power, reactive and active power factor for every submeter too. And also we can check the minimum and maximum measurements. Also through this the display setup, now we are going to write the password, and as you mentioned, it's very hard to work with this display. That's why the BFM II wants to make calibration for our display, for our stylus too. Now we are going to do that, and after that we can save the calibration results. Now trying to do another step, and after these calibration results, after we save the calibration results, it will be more easier to work with that. Now we're going to change the language for Russian. After we save the results, we will go to the menu in Russian. And also I want to show you the log section. We can see the event log from the display, and now we are going to see all information about what this device write in his memory, and what when the device was power up and power down and so on. We can change some parameters in the device by writing the password. It's 9 for every SATEC devices. We can check the serial parameters for serial port about the RS485. we can see there's some kind of display identification. We can also write the customer name. Here we go, and we can change, there's some kind of standby mode. We can change the brightness and so on. Okay. Also, we can change the network parameters. Now it's in Russian, but it's not a problem. We can change the device IP address through this menu. Now we're going to do that. We can change the device IP address, and also it's okay. It's great. And we can need to change the network gateway. It must be same for our network of our PC. So yes. Okay. Also, we can change the time and date of this device. We can also reset some parameters, file logs, event logs, and so on. Also, we can change the main parameters, the frequency. Okay, and also we can see these parameters of voltage and so on in the Russian. Now let's have a look how to configure the BFM II DFR in the past software. Here we have our site, and let's go to the tools, configuration. Here we can select the device address, device ID, and model of our SATEC meter. After that, go to the general setup, and the main difference between the other SATEC devices is that we have a list of the submeter. And in the BFM II DFR we have about 12 submeters, and for every submeter we can change the phases for our connections, CT primary, and also we can change their submeter label. For example, feeder number 34, and for example kitchen, we can write it to the submeter label. We can change the CT primary to for this one, for example 200. And after that we need to send these setups to the device. And also we can change the setups for control our alarm set points. For example, we have here some kind of list of triggers, low voltage, high voltage, but we need to write for some kind of data in the data log number 1 for every 15 minutes, for example. What else? We have here some setups for transformer correction, but it's not, frankly, it's not necessary for us, but we can do it too. Also, we can change some parameters for digital inputs, relay outputs models, some kind of modes for that. Also, we have here the analog input setup, some kind of counters if we want, and so on. But I want to show you more about the submeters. To change the submeter, we need to change the device ID. And for every submeter, we have different kind of set points. They are different for every set points. We can change here the trigger, and also we can change the memory lock for every submeter. For about 16 parameters we can write in the memory of the this device. And let's change it again. Yes, and we have here another the set points, and here if we will have this online device we will change this data log parameter. And the main difference between the BFM2 and BFM2 DFR is that in DFR we have the fault recorder, where we in this menu we can change some kind of fault recording setups, where we need to save it, and we need to have the recorder enabled. We can change the setups for waveform recorder, for about the samples, cycles, and for define the fault we need to select all the channels, all the voltages and currents. So after that we can see the fault log. Here we will have information about the fault category, event, phase, and so on. And also we can see some information about the event log, about the events of the device, the data log for every submeter, and also we can see the waveform and phasor of the faults that we will have in the different feeders of the grid. The BFM II DFR combines the functions of multi-channel fault recorder measurement and monitoring to provide a complete solution for transformer substations and industrial automation. Subscribe to the channel, there will be more videos about the use of SATEC equipment.